So here we go. We're going to do linear and quadratic systems. So the solution of a linear quadratic system consists of the intersections of the graph of a line, hence linear, and a quadratic, which is a parabola, of a line and a parabola. So the solution of a linear quadratic pair may consist of either 2 points, 1 point, or 0 points. Basically, you can have a parabola that looks like this and a line that intersects, and they intersect twice. You could have a parabola looking again like this, and maybe you have a line that's tangent to the parabola where there's only 1 point of intersection. Or maybe there is something that happens where you've got a parabola and a line that never intersect at all. Well, we're only going to be concerned about these guys. We're only going to be giving you problems that have 2 solutions. Okay. When you solve a linear quadratic, you need to draw the graphs of both equations on the same coordinate plane. When you're graphing the quadratic, you need to create a table of values centered on the vertex. And if you remember being centered on the vertex, you need to use the axis of symmetry equation. And that's all about what the x is. And the x is the formula of negative b over 2a. That gave you the x-coordinate of the vertex. The y-coordinate of the vertex came from plugging in the x value into your quadratic equation, which is y equals ax squared plus bx plus c. Once you get the vertex, you can go right to the calculator. So after you graph your parabola using a table of values and you graph your line just using the regular line stuff, you are going to find the common solutions, the points of intersection of the 2 graphs. You might want to check your solutions on the calculator because these won't be as easy to read because the parabolas, they're not going to be perfect, but the lines should be. You will have to do second trace intersect, enter, 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 and you need to do this thing twice to get the 2 different points. Your solutions are going to be written as 2 separate ordered pairs. Okay, so let's see if we can put this thing into action. The first one, let's graph the line first, y equals negative x plus 3. These are equations, not inequalities. There's no shading anywhere. The line, you begin at 3, down 1 to the right 1, down 1 to the right 1, and there's your line. For the quadratic, you need to find the vertex. So you need to realize that x equals negative b over twice a, which is negative b. b actually in this case is negative 2. Remember, y equals ax squared plus bx plus c. The thing attached to the x is a negative 2. Over 2a, the thing attached to the x squared is a 1. When you do the math here, double negatives give you a positive 2 over 2, which means it's a 1. So that's your x-coordinate of your vertex. To find your y-coordinate, you take the quadratic, because that's what we're graphing here, x squared minus 2x plus 1, and you substitute in what the x is, which means 1's go here. When this math gets done, you get y equals 1 squared, which is 1, minus 2 plus 1. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So what you need to do for your quadratic is you need to create a table of values centered on this vertex, which means in the graphing calculator, you're going to plug in the quadratic and you're going to find the table of values that matches to this, remembering that you always do the 2 numbers right after and the 2 numbers right before. That's a 0. So we're going to go to the graphing calculator. And we are going to just type in the quadratic for now. The quadratic, y equals x squared minus 2x plus 1. You can take a look at that parabola real fast. There it is. You can see your vertex is that 1, 0. And now you're going to go to your table of values. You're going to find that 1, 0, which is here, but you got to have enough room to use the other values. So I'm just going to kind of center this thing up here. And those are the order pairs you're going to choose. So it's negative 1, 4, 0, 1, vertex, 2, 1, and then 3, 4. So I'm going to put those things down here. So we've got negative 1, comma 4, 0, comma 1. We already have the vertex, 2, 1, 3, 4. If we plot this, negative 1, comma 4. Whoops, that's too high. Sorry. Let's fix this. Boom. Okay, try this again. So negative 1 comma 4 is here, and then 0 comma 1 is here, 1 0, 2 1, and 3 4. And then here is your parabola. Well, there are 2 points of intersection, and you should be able to see them pretty clearly. They're right here, and they're right here. We've got to find those ordered pairs. So here's where you go back to your calculator. In y2, go back to y equals, in y2 you plot your line, negative x plus 3. Take a look just to make sure that your graphs look the same. They do. So now we're going to use the calculator to find the point of intersection. Second trace, intersect, and then you're going to hit enter once, twice, 3 times. So the point up here on the top left is negative 1 comma 4. So right now we know for our solutions, one of the ordered pairs is negative 1 comma 4. That was this one right here. And now we have to find the other ordered pair. So we go back to the calculator. And you do second trace intersect again. But now when you do that, if you hit enter 3 times with the cursor blinking on the point that you were just on, you're not going to get the second answer. You need to take the arrow pad, move your cursor so it goes to the other side, away from the first point, over close to the second point that you want, then hit enter 3 times. And the second point of intersection is 2 comma 1. Okay, and that's this one. All right, so hopefully that is good for you. Let's do one more of these, and then you guys can work on the homework. Alrighty, let's graph the line first. To graph the line, you need to add x to both sides. So you get y equals x minus 2. You begin at negative 2. Up 1 over 1 is your slope. And there's your line. For the parabola, we know that we've got to do x equals negative b over 2a. So it's negative b, over 2a. And the thing that's attached to the x is a negative 6. The thing attached to the x squared is a 1. Double negatives up top. If you do 6 divided by 2, you're going to get 3 for your x coordinate. Now you take your quadratic again, which is x squared minus 6x plus 4. You plug in the x value. You do the math. 3 squared is 9 minus 18 plus 4. Y equals negative 9 plus 4. Y equals negative 5. So then, you are going to center your graph around 3, negative 5, knowing that the numbers above that should be 2 and 1, and the numbers below that should be 4 and 5. You're going to go to your calculator. You're going to clear out all this old stuff. You're going to type in your quadratic, x squared minus 6x plus 4. Whoopsie. Let's try that again. 6x plus 4. You're going to graph it. And that looks like your vertex, 3, negative 5. Go to your table of values. Find that vertex, 3, negative 5. There it is. And then use all the points around it. Use the 1, the 2, the 4, and the 5. So there we go. So these points that we're going to use are going to be 1, negative 1, 2, negative 4, vertex we already have, 4, negative 4, 5, negative 1. So let's see, 1, negative 1 is here, 2, negative 4 is here, 3, negative 5 is here, 4, negative 4, 5, negative 1. There we go. And we're looking for 2 points of intersection. That would be here and here. So let's see if we can go to the calculator. Let me just get the solutions. So it's going to be x comma y and x comma y. All right, let's go back to the calculator. In y equals, get the equation of the line. The line in y2 was x minus 2. And there's the graph. Let's see. It looks exactly like what we have. Second trace, intersect, enter, enter, enter. The point that's on the left is 1, negative 1. So we've got 1, negative 1. Let's go for the point on the right. Second trace, intersect. move the cursor, enter, enter, enter. 6, 4. And that is it. All right, so you should be good for the homework.